So this is problem number 3 on the review for test number 3, and it's asking us to determine the force in each member of the truss and state if they are in tension or compression. I have already drawn the free body diagram of the truss as a whole. Notice that theta is 0, so C of y is just a vertical component. It is not set at an angle. And A is a pin, so we have two forces at A. So let's solve for our support reactions. So I'm going to start with doing the forces in the x direction. So I can say positive forces in the x direction equal 0. So all I've got in the x direction, I've got negative a of x and 3 to the right equals 0. So therefore a of x equals 3 kilonewtons. And it's to the left, like I assumed. And then let's do the moments. Let's sum the moments about point A. It really doesn't matter right now because we could do them about C also. If I sum the moments about point A, I'm going to have the 4 kilonewton force down is negative, and it is 2 meters away. And then I've got the 3 kilonewton force. It is also negative 3, and it is 1.5 meters away. And then I've got C of y, which is positive, and it is the whole distance away of 4 equals 0. And if I solve that for C of y, I get that C of y equals 3.125 kilonewtons. And it is in the up direction because it came out positive, and that's what I assumed. So the last one I have is to get A of y. So now I'm going to sum the forces in the y direction. And I've got A of y minus 4 plus the 3.125 equals 0. So I'm going to get that A of y equals 0.875 kilonewtons, and it was positive, so it is also in the upward direction. All right, now we need to figure out how we're going to find our forces in the truss. I'm going to start with C because I think it looks the easiest because I have one force off at an angle and one force horizontal. I could also start at A. You can pick, you should get the same answers regardless of where you start. So I'm going to start at C. So I'm going to draw my free body diagram at C. I've got my y-axis, I've got my x-axis, and then my forces, I've got C of y, which is up 3.125. Then I've got to the left, I've got FBC. And then at an angle, I've got FCD. Let's put our geometry on there. And I know that it is a 3, 4, 5 triangle because one side is 1.5, one side is 2, which if I double is a 3, 4, 5 triangle. You could also do 1.5, 2, and 2.5. That would be fine. It's the same thing. So I'm going to sum my forces in the y direction first so that I only am solving for FCD. 0, so I'm going to have 3.125 plus FCD, and its vertical component is 3 over 5 equals 0. So I'm going to get that FCD is negative, which means it's in compression. Negative 5.2083 kilonewtons. And now I can sum my forces in the x direction equals 0, and I'm going to have negative FBC, and in my drawing I said FCD was negative, but remember it is also negative, which means it is going to come out being positive, and its x component is 4/5 equals 0. So FBC is actually going to be positive. FBC equals 4.167 kilonewtons. It is positive, so it is in tension. Now that I have that information, I am going to go to B, point B. You can go wherever you think you have the most information of everything you need. I'm just going to choose to go to B, because I think that I can easily find, now that I have force BC, I can easily find all the forces at B. So I'm going to draw my axis, draw my x-axis, and this is just, I've got forces up and down, and I've got forces left and right. So I'm going to have, to the left, I have FAB. To the right, I have FBC, which is 4.167 kilonewtons. I've got pulling down, I've got 4 kilonewtons, and then I've got a force going up of FBD. So this is pretty simple. I can solve for my forces in the, it doesn't matter if you do X or Y first. I'm just going to do Y first. But you could do either one, because they are not dependent on each other in this example. So I'm going to get negative 4 plus FBD equals 0. So FBD equals 4 kilonewtons. Then if I do the horizontal, sum of the forces in the x direction equals 0. I'm going to have that 4.167 minus FAB equals 0. So I'm going to get that FAB equals 4.167 kilonewtons. It is also positive, so it is in tension. And finally, I'm going to do my free body diagram at A. I could do at D. The only thing I have left to solve for is FAD. I've solved for everything else, but I'm going to choose to do it at A. So I've got my vertical, got my X. All right, I have got forces in the X. I've got one force up in the Y. And then I've got at an angle, I've got FAD. So going to the left, I have 4.167. That's what I just solved for. Going up is the reaction support at A, which is 0.875 kilonewtons. I've got going to the left, which I solved for, is 3 kilonewtons. And then I've got the geometry of AD, which is 4, 3, 5. So I only need to solve for FAD. It's the only unknown I have. It doesn't matter if I do X or Y. I'm going to do Y because I think it's easier, because I have more forces in the X. So I'm going to say that sum of the forces in the Y equals 0. And in the Y, I've got 0.875. And then I've got the component of FAD, that is vertical, which is 3/5 equals 0. So I'm going to get FAD. It's going to come out being negative, so it's in compression. Negative 1.458 kilonewtons. Now for good practice, you should put everything in one box so it's easy for your teacher. So I'm going to do that real quick here. I'm going to say we have FCD equals 5.21 kilonewtons in compression. We have FBC, which is 4.17 kilonewtons in tension. We've got FBD, which equals 4 kilonewtons, also in tension. I've got FAB equals 4.17 kilonewtons, also in tension. And then I've got my last one, FAD, which is 1.46 kilonewtons, and it was negative, so it is in compression. Put a box around it, and that is the end of problem 3.